We're going to look at the normal distribution. So, the normal distribution is a function which is quite commonly known as the bell curve, and there are different properties about it. Maximum value is always at the mean, because that's where the majority of the data is, and it's always symmetrical. If you ever tried to find the area throughout the whole of the bottom, it's equal to 1. However, you usually can't manually do it, and so pretty much for most of the section we're going to use the cars, except if you go to this particular slide, you'll see that there are special values that we need to note. So approximately 68% of the population will fall within one standard deviation of a mean. So that means within the first mean, we have to remember that it's equal to 0.68. And then within two standard deviations, we have 0.95. And then, unlikely that you'll use it, but within 3, it's 0.997. So these are the values that you have to remember, and you will be asked to calculate stuff off it. For example, if it ever asks you from the mean to one standard deviation on the positive side, that would then be 0.34, for example. So you'll be asked to do stuff like that by hand. All right, the heights of the women in a particular town are normally distributed with a mean of 165 and a standard deviation of 9 centimeters. A. What is the approximate probability that a woman chosen at random has a height which is between 156 and 174? So what we need to do is we need to determine how many standard deviations each of these are away. So 156 minus 165, notice that I always do the one given minus it. There's a reason for that. So that gives us a 9, negative 9. So this is, I'll leave it there for now. You'll see why. So 174 minus 165 is then also equal to 9. So this is one standard deviation to the left and one standard deviation to the right. So that means we want the probability of one standard deviation to the left of a mean, and we'll use the next one standard deviation to the right, which is then 0.68. All right, B. What is the approximate probability that a woman chosen at random is taller than 174? Now, 174, if you remember, is our bell curve. We have mean here. We have the mean plus one standard deviation to here. We want taller than 174, so it's going to be this area down here. Now, if you remember, this is symmetrical. So if I wanted the section to the left of this, that's going to be 50%. Because this side is 50%, this side must also be 50%. That means, so long as we know what the section in here is, we can find out the rest. Turns out, because it's 0.68 for the middle section, this will then be half of that, so this will then be 0.34. So that means to find the rest of this, we do 0.5, because it's 50%, minus 0.34, which then gives us 0.16. So this is the probability of the woman chosen at random is taller than 174. Now you might then ask, does it matter whether or not we put an equal sign on? No, it does not. Because remember, with anything that's continuous, we just find the area underneath, and it doesn't change whether or not you are above or below it. Okay, C. What approximate percentage of women in this particular town are shorter than 147? So 147 minus 165 gives us negative 18. So this is 2 standard deviations to the left. Again, have a look at your distribution. It's not drawn out very nicely, but anyway. So here's the mean. Here's 1 standard deviation. And then here is 2 standard deviations. Now, remember 2 standard deviations is 0.95 for the section in between. So 1 standard deviation, 2 standard deviation. If we went from here to here, that would be 0.95. We want shorter than that, so we want to go to this side. Now, because it's symmetrical, we know that if we do 1 minus 0.95, that gives us the section to the left. Oh my god, come on, rub out. This gives us this section and this section. However, we just want the bit on the left, so then we need to halve it. So therefore, the probability of it being shorter, so less than 147, is equal to 0.025. I might rewrite this. So what the probability for this one is 156 x to 174.